Hello, my name is Fernando Rodriguez. I'm here at the Victor Valley College. I'm the instructor for the CT 128 residential wiring class. Today we're going to be talking about residential wiring. We're talking about single pole breakers. That's a single pole breaker right there. And we're going to be talking about two pole breakers, okay, and their associated loads. One of the things I want to discuss first is the testing protocol. Okay, anytime we come in here, you got to check. This is not plugged in, so we are not energized up here. But testing protocol, every time I have my guys first put their meter on volts, AC. You can hang this meter, it's got a magnet on it. Just hang it right there. From this lug to the neutral bus should be 110 volts. From this lug to the ground bus should also be 110 volts. Same thing with this lug. This lug to the neutral bus is 110 volts. Same lug to the ground bus, 110 volts. If you check lug to lug right here, you'll read 240 volts. Obviously, I'm not reading anything right now because we are not energized. So, safety protocol. Also, the gloves, proper PPE, long sleeve shirts, the gloves, safety glasses, part of the proper protocol anytime we're working on this. And as my class knows, anytime something is going to be energized, they holler, "Coming hot." That way everybody in the classroom knows, or everybody in the lab knows. And also, they're hollering breaker close whenever they close a breaker, and then they continue to test. Okay? You're always checking, testing to make sure you're establishing good habits. Okay, the first thing I'd like to do is talk about the bus in here. These components, grab my laser pointer here, my pencil, okay? This lug right here is associated with this, and this. This lug right here is associated with this one, this one, this one. They alternate, it's every other one. So consequently, when I insert a single pole breaker, these are stab-on, so you just stab them in like this. I'm only making contact with one bus. So now I can measure from the screw here, once the breaker's closed, I can measure from this screw to the neutral bus and the ground bus, and I will also read 110 volts. The other thing, I am going to install a two-pole breaker now. You're going to see the difference. Insert the same way. You hook them right here, and then you just stab it in. Should be in the open position. Now you can see that a two-pole breaker is occupying two spaces. So now, these two lugs right here on the two-pole breaker represent these two lugs up here. In other words, if I check with the meter at those 2 points, I will be getting 240 volts. I could check one at a time to the neutral bus or the ground bus, I will get 110. But you have to know that this two-pole breaker is for a 240 volt load. Okay? Having said that, I want you to know they come in 20 amps, they come in 15 amps, they come in, this particular one right here is a two-pole 30. This particular one here is a two-pole 50. Okay? This two-pole 30 amp breaker would require number 10 conductors. If you look right down here and look at this is typical to the wall-mounted range you have in the kitchen on the CT 120A residential drawings. This is the same receptacle, okay, with number 10 wire. This is the same as the Romex they use for 14 and 12-3, okay? Only now the conductors are bigger, okay, to accommodate the 30 amps. These are number 10. The number 10, according to the National Electrical Code, requires a 30 amp breaker, 30 amp rated receptacles, the conductors also have to be rated for 30 amps, according to the NEC. I'm not going to terminate this, but I do want to point something out. These 2 points right here, let me get my laser pointer again. These 2 points right here, these are your hots, okay? This right here is your neutral. This right here is your ground. Now, if I could go back to the breaker, these 2 points right here, these are your 2 hots. Okay, the other side of this neutral right here is going to land on the neutral bus right there. It's no different than any other breaker. Most of them do have a neutral, some don't. In this case, for the wall-mounted range, we do require a neutral. The reason we require a neutral is because you have a clock. You probably have electronic ignition in your stove or your wall-mounted range. There are different components. There's a timer in there. There are all kinds of timing relays that require 110 volts. So from here to here or here to here, you do have that 110 volts. So when you plug in the electric range, you have all those options available to you. Okay. On the other hand, let's take a look at this breaker. This is a 2-pole 50 amp breaker, 50. Okay? This breaker is associated with this type of receptacle. This is the type of receptacle I have in my shop for my welding machines. All my welding machines are 220 volts. This is 220 volts, 240 volts at 50 amps. You can see proportionately the conductor size. This is the number 8. If you compare the number 8 to the number 10, you see a big difference in size. Okay, it's bigger because it's going to handle more current. Okay, it's rated for 50 amps. The receptacle is rated for 50 amps, as well as the 2-pole breaker. They all have to be compatible, all rated for 50 amps for protection of yourself, protection of the equipment that you're using, and protection of other people that may not know what you know. Okay? So at this time, what I want to do is look at certain components. For example, in your drawings, this set of drawings here, this is page 6. It has a schedule of special purpose outlets. This is where you're going to find all your 220 loads. I have highlighted them. I put down the conductor size according to the NEC, National Electrical Code, Article 315.10, or 310.15, excuse me. And over here are the panel schedules. There are 2 panels in this residence. You have panel A and panel B. Panel A is your main panel. You can see up at the top here, if you're looking at your drawings, you have a 200 amp main breaker. Now I've also highlighted on here your 220 or your 2-pole breakers. Okay, they're highlighted throughout, they're highlighted. As you scroll all the way down on this side, you're going to see a 2-pole breaker also. It says 100 amps. That is your feed or your breaker that's protecting this panel, panel B. If you go to panel B, you can see as well, gotta stop shaking. Okay, you can see as well, I have highlighted the 240 volt loads that are in panel B. Most of these out of panel B are in the kitchen, not all of them. You have components in your lower floor in the basement that are 240 volt, and you have components mostly in the kitchen and the laundry area that are 240 volts. Okay? What you do is you're going to, if we come over here, you're going to pull something like this. This is Romex. You're going to pull this. The closer you can get this to the kitchen range or the wall-mounted cooktop, the cheaper it is going to be for you, because this is not cheap. It's very expensive. If you look at your drawings, I'm going to refer to the page, sheet 9, shows the kitchen all the way to the left-hand side of your drawings. If you look at where most of the kitchen components come from, they come from over here where panel B is in the basement. That's quite a distance. So if you're having to pay for this, that's going to cost you a lot of money. Panel A is sitting right underneath the kitchen in the basement. So this is something you might want to consider, and you have to speak to somebody. You can't just arbitrarily make these changes on your own. Ask the question, is it possible to move these loads to panel A? Okay, to make the distance shorter, to save the owner some money. Okay? And more than likely the answer will be yes. But if you don't ask, then you're not going to get an answer. Okay? So, on the assignment, you had to find 6 two-pole breakers. You have to identify them. You have to identify where they are, the conductor size, and you have to identify their purpose. Okay? Make a list, write them down. It's the same thing as searching your blueprints. Same thing, no difference. Also part of the assignment is you have to find 12 single pole loads, any single pole loads, 12 of them. You have 2 panels to pick from, panel A and panel B. Okay? Take your time, research this, and just, educate yourself into what a journeyman electrician would be doing if he was looking at this. If I were looking at this, I'm studying this. I'm studying this long before I set foot on the job. So when I set foot on the job, I know exactly where I'm going, what I'm doing, the wire I'm using, all my components. Everything has been purchased, because once you get on the job, it's time. Time is money. Okay, you have to know what you're doing, and it'll be pretty obvious to the owners or somebody that's watching you. If you don't know what you're doing, it's going to be evident. So, getting back to the main crux of this thing, I do want to discuss another component. I'm going to install another single pole breaker. It's a little different, okay? This particular one is a 15 amp single pole, but if you notice on here, there are 2 toggles. Okay, you could actually put 2 loads on there. Those are rated for 15 amps. Okay, same thing with this guy. You could actually install 2 circuits, 2 20 amp circuits right on there. Okay, they're still single pole breakers, but they are called twins. Okay, I'm going to introduce another component. This is now a 2-pole breaker, but take a good look at it. You have 2 sets of twins. Those 2 are tied together in the center, and you actuate them together, and the same thing with these guys. In other words, you can handle 240 loads. The outside ones are rated for 20 amps. The inside ones are rated for 30. Okay? You install them the same way. I'm going to install it down here so you can see that this matches. Yeah, right there. This matches this 2-pole breaker. This is a 2-pole breaker. So what you have consequently between here and here, or if I could, this point and this point right there, 240 volts. Okay? You could also have the 240 volts from here and here. So you can look at your prints. Where do you have a 2-pole 30 or a 2-pole 20 where you might be able to combine all this? Okay? These are number 10s right here for the 2-pole 30, and these are number 12s. And those would be a 12-3 and a 10-3. This is a 10-3. So you want to pull a 10-3 to this device. The 10-3 to your outlet for your electric range or your wall-mounted oven. Okay? The other thing you can do is, if you look at your drawings in the kitchen, you have your garbage disposal and your washing machine adjacent to one another. What you want to do there is pull a 12-3. Why? Because those are 2 circuits. And those are dedicated circuits for the garbage disposal and the washing machine. That's it. So you want to pull a 12-3, not an individual circuit for each one. Okay? And the same thing could be true of the opposite side of the house, where you have the bathroom, you have a 15 amp circuit for your lighting, and right next door in the master bedroom, you have a 15 amp circuit for your lighting in there. You could pull a 14-3 and split that circuit between the bedroom lighting and bathroom lighting, share the neutral. Okay? There's a ton of possibilities here. Unless you come, or we have this lab setting and we can experiment with this kind of stuff and do the testing, it's really difficult. And to me, guys, or ladies, I think this is an important component of learning the wiring. It's unfortunate that we do not have access to the lab, and I understand that. But this is where we are, given today's events. But hopefully I can give you, or I have given you enough information where you can start thinking about the possibilities here. Okay, one more thing that I'm going to add. Just because, like I have two 20 amp circuits here, or for example, let me go back a couple of pages. What I have here, and I got to take off my glasses, I can't really read with those. I have a 2-pole 20 amp breaker there, and a 2-pole 20 amp breaker. Where is it? Am I looking at the wrong one? Oh yeah, right here. I'm sorry, 2-pole 20 amp breaker there and 2-pole 20 amp breaker there. There's nothing that says you can't move that breaker there. Okay, you can. And what you could do, you could do something like this. Put those guys on something like this, because besides that one, I also have this particular one's difficult to read because it's older, but they're all 20 amp 2-pole 20s. This is for a 240 volt load. Two 240 volt loads. So you could actually move this breaker up into this space, move the 70 amp breaker to that space. There's all kinds of things you could do to accommodate yourself, to make things easier for yourself. But when you start moving things around like this is where you have to really pay attention, because what's going on here, and this is already done by design. They try to balance the load between here and here. So let's say it's a 100 amp panel and you're pulling about 75 amps, okay? So you want 75 amps here, 75 amps there. You want to balance the load. This is typically what the engineers are doing by doing this. Okay, having said that, in a home or in a business or in an industry, none of these are on all the time. In other words, the lights aren't on all the time. You aren't using the electric range all the time. You aren't using the washing machine all the time, and the water heater isn't on all the time. So it's hard to maintain that balance. So if you do start swapping things around, pay attention to what you're swapping around, look at where they're going, try to keep the load balanced. Okay? There's all kinds of options here.